We did till MCQ20, right?
Yes, sir.
Before. And I told you to try some others,
Yes,
right?
sir. Sir, sir, I can't understand the question of most of them.
Which one?
Most of the MCQs. Sir, most of the MCQs, sir. I have problem.
Okay, I will see. Uh, After 20, till 20 you understood, right? We explained
Yes,
all.
sir.
So if you get similar questions, then you can do it, right?
Sir,
Yeah. So this one, like this one, 21, it is related to evaporation, right? Can you read the question? Farabi, read the question.
sir, 21.
Yeah,
Water
21.
is poured into 4 dishes. In 2 of the dishes, the water has a small surface area, and the other 2 it has a large surface area. The water in 2 of the dishes is cool, and the water in the other 2 is warm. From which dish does the water evaporate the quickest?
Yeah. So about evaporation, I gave you 4 points, right? When the
Yes, sir.
evaporation will be more and evaporation will be less in your copy. Can you check this one?
Sir, when evaporation is more and when evaporation is less.
Yeah, yeah. In your copy, physics copy, coaching's one, you have this note on evaporation that when the evaporation will be more and when evaporation will be less. That that there are 4 points I gave.
The evaporation increases if the surface area is more.
So here you got about surface area. They are saying when the evaporation will be quickest. So uh, which uh, which one you will take? Is it large or small?
Large.
So I think if you are going through the notes, you could answer it, right? You could find it. Then about temperature, what is written there?
If the temperature is more,
Mm-hmm. Then
then then the air draft is more, airflow is more.
mm, if the temperature is more, then the evaporation is more, right?
Yes, sir.
So which one you'll take from temperature for evaporate quickest? We'll take cool or warm.
Sir, cool.
Why cool? You already told if temperature is more, then evaporation
Oh,
is more.
warm.
Warm. So it's simple, right? This question is very simple question. So did you try it actually properly?
Yes, sir.
So you did not go through the notes.
Yes,
The
sir.
notes I gave you. I told you to please study and revise more and more. Otherwise, you cannot go forward. Yeah. So the answer of 21 is
A. No,
A.
B. Sorry,
B
B.
is B. Be careful. Be careful. Look, you know all the things, but you are doing wrong. Be careful, huh? 22. Yeah.
When a person slides out of a warm swimming pool on a hot summer day, he feels cold. Why does this happen?
Yeah. This type of questions we got at least 3 before. and I explained it many
Yes, sir.
times with your practical life. So, which one will be the answer about this one? Why the person is feeling cold?
Sir, as the water droplets increases the surface area,
No,
the water takes heat from his body to evaporate,
yes, this one. The water takes heat from his
and
body.
that
That's why
is
he is
considered
feeling cold.
cleansing.
I
Yes,
even
sir.
I can remember twice I told you in
Yes,
last
sir.
class that if you are taking bath, there are some water left on your body, and when this water evaporates, then you are feeling cold because this water is taking some heat from your skin to be evaporated, right? So is it clear, Farabi? 22, the answer is D. Then 23.
Different amounts of energy are supplied to copper blocks of different masses. Which block experiences the greatest temperature change?
Yeah, this one is not beyond your knowledge, but here you have to think or you have to calculate. So it's related to uh, mass, energy supplied, and temperature change, right?
Yes, sir.
Okay, so which formula do you think that you can use to understand it? They are saying copper blocks, right? All are
Yes, sir.
copper blocks. So if they are of the same material, copper, then they have the same specific heat capacity, right? If
Yes, sir.
there is anything with temperature change, then we will do with specific heat capacity, right?
Yes, sir.
So we will first write the formula of specific heat capacity. What is the formula?
So, let me check.
You forgot. We did some
The
questions on
formula of
this.
specific capacity.
Yes, yes.
Ah, the thermal energy by mass into change in temperature equals to Q by M del theta.
So they are asking you about the greatest temperature change, right? So you have to make
Yes, sir.
del theta as the subject. Okay. So if you make the del theta as subject, then how can you write the formula?
The del theta.
You can rearrange the formula, right?
Yes, sir. Del theta is equals to Q by Cm.
Hmm?
Q by Cm. Cm.
Del theta equals
Q by Cm.
Q by Cm. Okay. Q by Cm. C is, I told you that C is same for all, right?
Yes, sir.
So it's related to Q by M.
Yes, sir.
So you have to check with all of them that which ratio is becoming greatest for Q by M. This one is Q, right?
Yes, sir.
Energy supplied, and this one is
M.
M.
200 by
So
0.1.
200 by 0.1, 200 by 0.2, 600 by 0.4, then 400 by 0.8. All of them you have to uh, calculate, and you check which one is giving you greatest answer. That one is greatest temperature change. So on your copy, please write this. The formula you
Yes,
should
sir.
write. MCQ for MCQ 23, del theta equals
Del
what?
theta is equals well,
Q
P
by
by M.
M.
Q
Q
by M.
by cm, right? But c is constant for all, right? That's why
Yes,
if
sir.
it's enough to q by m, if you write
The answer is A.
how
No, sir. One minute. Yes,
answer
one
is
second.
a.
Sir, not A. Sorry, sir. I'm
For a it's coming 2000, right?
yes, sir.
For b it's coming 1000.
1000.
For c is coming
500.
how much?
And for D it is 500.
For d it is 500. For c how much?
For D two.
For c how much?
Sir, 1 minute. Um, Sir, for C it is 1500. Sorry,
1500. So you got for a 2000.
2000.
For b you got 1000. Please write
Yes,
on
sir.
your copy. Please write this
Yes, sir.
thing. For a it is 2000. For b it is
1000.
1000. Then 1500. Then 500.
Then
Right?
750. 750. No, sir, 500. Sorry.
For d it is 500. Right?
Yes, sir.
So which one is giving you greatest?
A.
A 2000. Right? So
Yes,
our
sir.
answer is A. Our answer is A. So it is
A.
clear to you, right?
Yes, sir.
I'm also writing here. C is constant here, right?
Yes, sir.
Why it is same? All are copper, right?
Yes,
C
sir.
same. I'm writing here.
Sir, who will be our take our biology teacher now, sir? Biology.
Biology, you have a very good teacher already.
Yes, sir.
Mr. Golam Samdan is there, right? And also there is Atay Rabbi. So anyone can take. Most probably Golam Samdani sir is taking.
And chemistry.
Which one?
Chemistry.
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 Chemistry. There is Atay
No,
Rabbi
come.
sir. There is Atay Rabbi sir for chemistry. Uh, Last year he took your chemistry class, right?
Yes, sir.
Yeah. He is also a good teacher, right?
Yes, sir.
So all the subjects you are okay. So no problem. So we can go to 24, right?
Yes, sir.
Till 23 you understood, right?
Yes, sir.
So do you think these are very difficult thing or it is
No,
beyond your
sir.
knowledge? All these
No, sir.
questions. So why you are saying that I don't understand or I don't get the answer? The problem is you don't want to do hard labor. If you are spoon feed it, then you can find, right?
Yes, sir.
Like someone is using a spoon to feed you. Okay, then 24. Continue 24.
Air is heated in a sealed container with constant volume. Why does the air pressure increase when the temperature
So
increases?
constant volume means what? Sealed container. If it is sealed container, we got one idea. If it is sealed container and the temperature increases, what will happen? Hmm? The molecules are moving faster,
Molecules
right?
will moving faster. Yes, sir.
Yeah, molecules will move faster. So if they are moving faster, what they will do?
They will bounce off each other more frequently
Here you say, why does the air pressure increase
when
when
the
the
temperature
temperature
increases.
increases? The pressure is applied on the wall of the container, right?
Yes, sir.
That's why this one will be the more appropriate answer. The air molecules bounce off the walls more frequently, right?
Yes, sir.
Uh, this one, the air molecules bounce off each other more frequently.
Yes,
It's
sir.
not wrong, but as they are talking about the pressure, pressure happens on the container, right?
Yes, sir.
So it's more appropriate answer that the air molecules bounce off the walls more frequently. Clear?
Yes, sir.
Okay.
Yes, sir.
And if it was not sealed container, then the volume would be increased, right? The
Yes, sir.
volume will not be constant. The volume would be increased. That time we will have the answer A. The air molecules expand. Clear to you?
Yes, sir.
So you have to look this idea, this concept. I am repeating. This is third time in the same worksheet. So if you are getting the container is not sealed, then we expect that you can choose this answer, right? Without
Yes,
any
sir.
help. So now its answer is C, right?
Yes, sir.
Okay, then next.
The more
Next one.
energetic molecule in a liquid may escape from its top surface. What is the process for?
Yeah, the more energetic molecules. It's about what? It's about evaporation, right?
Evaporation.
Yeah, but you don't see here evaporation on the screen.
Sir.
It's in D. So the more energetic molecules in a liquid may escape from its top surface. It's related to evaporation, right?
Evaporation. Yes, sir.
It's very simple. So why you couldn't answer it?
Sir, I answered this one.
This one you could, right?
Yes, sir.
Okay, great. At least this one you could. So we have finished all the MCQs, right?
Yes, sir.
By finishing all these MCQs, you are now, you know, occupied or
Yes, sir.
enriched, or we can say you are well resourced by lots of knowledge to solve the structured part, right? You are
Yes, sir.
equipped with lots of you know weapons which can help you to solve the structured
Yes, sir.
questions successfully, right?
Yes, sir.
So can you try them? Structured
Yes, sir.
questions. Yeah, on your copy you should write the answer, huh? And you write structured questions, question 1, then continue reading the question.
A rock from space is traveling at high speed towards the Earth. Complete the equation for the kinetic energy of an object with the speed v and state. What any other terms in the equation represent?
Hmm. Yeah, what is the formula?
Half mv squared.
Very good. So you are using half mv square. What is m?
Mass.
Mass. So they already told about the speed v, right? And
Yes,
other
sir.
than v, you are using m. So you
Yes,
should
sir.
tell here. You should write here that m is the mass. Okay. They said it. You know. They said state what any other terms in the equation represent. So other terms means you are using other than speed you are using mass, right?
Yes, sir.
So you should identify it here that m is representing mass. That's it. So write it on your copy. kinetic energy equals half mv square. You give comma, then you write m is the mass of the object. So is it clear?
Yes.
Arabi, you
Yes, sir.
if you want to do good in exams, then you should also understand the language, right? What they are meaning.
Yes, sir.
Look, in this question, some of the students will not understand what they are saying. State what any other terms in the equation represent. Did you understand it
Yes, sir.
when you were reading this question?
Yes, sir.
Or you understood after my explanation?
When I read the question.
Okay, very good. You are a smarter boy. Now continue B.
Yeah.
Are you done with
So,
A?
yes, sir.
So continue B.
So can you please scroll down? It's on the worksheet is on the MCQ part. Now it's okay. The mass of the rock is 0.6 kg. When it hits the earth, its average temperature increases by 25 degrees Celsius. The specific heat capacity of the rock is 560 joule per kg degree Celsius. Calculate the increases in the internal energy of the rock.
So they are asking about the internal energy. That means we have here mass, right?
Yes,
M.
sir.
Then temperature increase. What it is? Del theta.
Del theta.
And we have C. His specific heat capacity. What we are going to find? Q, right?
Yes, sir.
Energy. So what should be the formula? Q equals
Q equals.
Q equals what? We are going to find Q, right?
Yes, sir.
Q
Yes, sir.
equals MC del theta.
C by
So
the MC del theta. Yes.
yeah, MC del theta. So you write the formula in your copy. Q equals MC del theta. Finish writing.
Yes, sir.
Put the
Sir, what is the
values.
C value of C?
Hmm?
Sir,
C is
please
specific
call
heat capacity. Specific heat capacity C.
560 and del theta
Del theta is
is
25.
25.
M is 0.6.
0.6.
Yeah. So what?
8400.
So what is the answer?
8400
So write it 8,400.
yes,
And what should be the unit for energy?
energy.
Energy unit.
Sir, kilo per joule.
Joule. Only joules. Here, joules.
So, yes, sir.
Energy you will get joule because kilogram will be cut. Uh, this one will be also cut. You see, when you will multiply mc del theta, m is kg. Uh, it is upper side, right? Kg. Then
Yes,
lower
sir.
side is kg. So cut. Kg will cut. Then degree Celsius upper side, this degree Celsius lower side. So it will also cut, right? You know about denominator and
Yes, sir.
numerator, right?
Yes, sir.
All will be cut. Only joules will be left. So the answer is joules. And energy is always joule. You know it, right? Work done, energy, always the unit is joules. You should remember it.
Yes, sir.
Then, then continue.
Use the answer BI to determine the minimal possible speed of the rock when it hits the earth.
Yeah. So you are going to find the speed, right?
Yes, sir.
From kinetic energy. This energy, the internal energy is converted to kinetic energy, right?
Yes, sir.
You see, they are saying when it hits the earth, that means the rock is hitting the earth and the heat energy is produced, right?
Yes, sir.
So the heat energy you got, that is the result of kinetic energy. That means kinetic energy converted to heat energy, isn't it? Whatever you got the internal energy increase, that is your kinetic energy. So you know the formula we did in one topic, topic 8. This formula half mv square ke equals half mv square. Then when we found v, we rearranged it, right? Can you remember that formula? If you make v as the subject, what will be the formula then? Farabi, hello Farabi. Farabi.
Sir, be the subject, no, sir?
Yeah, yeah, v is the subject. So what will be the formula?
Half mk.
You write the formula first. K
Yes,
equals half mv square. Then rearrange.
yes, sir.
Otherwise, you will not understand. It
E,
will not.
E equals to half half mv square.
Right, right this way. I am writing. You also write on your copy. Half mv square. mv square. Right. So
Yes,
you can write v square equals 2ke by m. Right.
yes, sir.
I am writing all the steps so that you can understand easily. Listen, Farabi, I am working hard for you, but you are not working hard for me. Am I right,
Yes, sir.
Farabi?
Yes, sir.
So, what you have to do? You do little bit hard work, right?
Yes, sir.
2ke by m we can write.
Yes, sir.
Then still we are not getting the formula. The formula is for speed only, not speed square. That's why you should write here speed. Then v equals square root this
Square
way.
root
Mm-hmm. Square root.
2k e by m.
Yeah, physics is what? In physics we learn maths also, right?
Yes,
Hard maths. Mathematics is the language of physics. Okay.
yes,
2ke by m. You are good in maths, so you should be also good in physics, right?
yes, sir.
So you write the values now. 2ke by m. Ke, kinetic energy, already I told you that internal energy is the kinetic energy. How much you got? 8,000, how much?
So,
Did you
8,400.
8,400. So 2 multiplied by 8,400. Then
7,400.
mass is how much? 0.60, right?
0.6.
So square root. Square root. Give square root. Then what is the answer coming? Check the answer.
Sir, 126.5.
126.5.
Yes, sir.
Okay, wait. Let me check. Your answer is correct or not. I'm checking because I did not memorize all the answer. I have to check in the mark scheme. It's not possible to memorize, right? All the things.
Sir.
Worksheet. Oh, 11, 20. Topic 11, question number 1 is going on, right? So, what is your answer, Farabi? Can you tell me again? Farabi, what's your
126.5.
1?
26.5.
26.5, but the answer is showing here 167. There you did some wrong in the calculation. 167. Check it again. Square root of 2
2
ke.
into
2,
4,000.
you give bracket. Inside the square root you give bracket. Then 2 multiplied by 8400, right?
Yes, sir.
Then divided by
0.3.
6, 0.6, then bracket close. Then you check how much is coming. Is it coming 167?
Yes, sir. 167.33.
So what was the wrong before? In
I didn't.
writing, during writing calculator, you should give bracket when you are doing this square root. Otherwise, the calculation is not coming clearly. Okay, be careful, huh? So clear, Farabi?
Yes.
You also understand how to use the calculator, right?
Yes,
In
sir.
physics. Okay, that's great. Now, let's go to again there. Okay. Is it clear now? Part B is over, right? B2.
Yes, sir.
B2 is over. Now we'll go for B3. So B3 you can't see, right?
Yes, sir.
Yeah, yeah. Can
That's
you
just
read?
one reason
Hmm.
why the. Sir, can you please scroll down?
Hmm. Yeah,
Uh, so just one reason why the speed determined in B2 is less than the actual speed of the rock when it hits the earth.
yeah. So they are saying, do you understand from the language what they are asking you?
Yes, sir.
What they are asking you?
They are asking me that.
The speed you got 167 meter per second,
Yes, sir.
that is less than the actual speed. The speed could be more,
Why?
right?
Yes, sir.
Now the speed you calculated, it is not giving you the actual speed. It is less than the actual speed. What is the reason? What is the
Hmm.
reason? Because you calculate the speed from the heat energy or internal energy, right? Farabi?
Yes, sir.
And heat energy you are getting, that is uh, not giving you the appropriate one, because there might be some heat energy lost in the surroundings, right? Farabi?
Yes, sir.
The temperature change is given 25 degrees Celsius. Uh, Maybe uh, there is some heat lost in the surroundings, that's why you got this one. But if there is no heat lost in the surroundings, then you could get even more, right? That's why you got
Yes.
less heat energy in the calculation. And as you got the less heat energy in calculation, you got less speed in speed calculation, right? So the
Yes,
main thing is some energy is lost in the surroundings. Okay, you can write
Okay.
here. B3, you write here in your copy that there is some heat energy lost in the surroundings. Okay,
Okay.
please write on your copy, otherwise you will forget. Then 4, 4 continue.
A
Before.
house has several solar panels on the roof. These panels use energy from the sun both to generate electricity and to raise the temperature of water that passes through tubes inside the panels.
Hmm.
At the same time, 51 kg of cold water is pumped through the panel. The temperature of the water increases to 15 degrees Celsius to 47 degrees Celsius.
Hmm. Yeah, continue.
It is the same water. The specific heat capacity of water is 42 to 100 joule per kg degree Celsius. Calculate the increase in thermal energy of the water.
Hmm. So you can do it, right? What is the formula? Just now we did another one with this formula. You have mass, you have temperature change, you have specific heat capacity, you have to find the energy, right? So what should be the formula?
Wait,
Just now we did uh, here. Here we did this formula, same formula, same. B1, the formula we did.
V
B,
equals to root over 2k E by M.
mm-hmm.
V
Q equal,
equals to root over 2k E by M.
you, no, what you are saying. This is about internal energy. We are not going for speed one, this one. You don't understand that you are given mass, you are given a specific heat capacity, temperature change, and which formula will be used? Is it related to speed or related to mass, energy, then temperature change and specific heat capacity? What is the formula then? Q equals,
Q equals
did
MC
you?
del theta.
Yes, that one. Please write it here. In B4 also write in your copy. Q equals MC del theta. Then put the values, get the answer. Tell me the answer. This time don't do mistake, okay? This is very simple one.
Sir, can I go to the next question?
How much you got here?
Oh,
MC del theta.
sir, what is the M, sir?
Hmm?
M
M is given here. You don't see here. M is the mass.
1.
51. Yeah.
What into 4200 into 15 into 45. No?
Again,
51 into 4200 into 45 minus 16.
yes, 45 minus 16 in bracket. 45 minus 16 will be in bracket.
Yes, sir, I know that.
Then how much it is? 45 minus 16.
6211 45 minus 16.
Yeah, yeah.
Sir, I calculated directly.
Okay, directly, what is your answer?
6211
60.
6211
Okay, okay. You are correct. Then what will be the unit?
unit. Joule.
Joule. Very good. Very good. So the unit should be joules. Okay. Now,
Yes, sir.
how many questions you have left? Question 2, then question 3, right?
Yes, sir.
Then question 4,
Four.
then question 5, question 6. So how many questions left? 5 questions left, right?
Five.
We did question 1, right?
Yes, sir.
And it is a big question, and you got many ideas here in this question. Now question 2 is not so big. Question 2 and only question 3, huh? These two questions are small questions. You will solve. This is your homework. Okay, Arabi,
Okay, sir.
you do these two questions at home and give me on Saturday. Clear?
Yes, sir. Clear.
Okay. Thank you so much. Now you have half an hour left. This half an hour you try these two questions so that you do not need to use other teachers' time. Okay, clear,
Clear.
Arabi? And after finishing
Clear.
these two questions in Messenger, you will tell me, sir, I did these two questions or tried.
Yes, sir.
At least I tried these two questions. Okay, thank you. Thank you so much, huh, for today. Allah Hafiz, huh?
Love you.